Before we get into the nitty-gritty of AI's ups and downs, can we rewind a bit? I'm kind of obsessed with how those early computer scientists dreamed so big, like creating actual intelligent machines. What was the vibe back then?
Totally, those early days were buzzing with possibility. The moment digital computers started gaining ground, the idea of artificial intelligence just took off. There was this sense that if you could describe intelligence, you could program it. People literally believed a theory of everything was just around the corner.
It's wild, right? They weren't just daydreaming, they were organizing workshops and coining terms. I heard about that famous Dartmouth Workshop. That was the official launchpad, wasn't it?
Exactly. The 1956 Dartmouth Workshop gathered some of the brightest minds. They were convinced that by nailing down the features of intelligence, machines could learn and reason just like us. It sounds ambitious now, but it genuinely set the tone for everything that followed.
That energy set the stage for a big split, though, didn't it? Suddenly you had camps arguing over the right way to build intelligent machines. There's mathematical logic on one side, and then inductive reasoning on the other.
Absolutely. And the divide was more than just academic. The math logic folks believed in set formulas like Newton's laws, so everything was crisp and predictable. On the flip side, the induction crowd wanted AI to find patterns from data, kind of how we learn from experience.
It's funny, because that debate still echoes today, like, do we trust the formula or the patterns we spot in a million examples?
Totally. The mathematical logic, people saw certainty as their superpower, while the data-driven folks argued for flexibility. But back then, the math logic side definitely had the upper hand.
So let's dig into that mathematical logic approach a bit. What makes it so attractive for building intelligent machines?
Well, it's all about strict reasoning. Think of classic formulas. You put in your known facts, follow logical rules like all humans are mortal. Socrates is a human, so Socrates is mortal. It's step by step, and you always know where you'll end up.
That predictability has its charm. No surprises, just clear answers. But isn't it a little rigid?
Exactly, that rigidity is both its strength and its weakness. It works beautifully when you have perfect information and clear rules, but the real world's messier than that.
On the flip side, inductive reasoning feels more like how we actually learn looking for patterns. Could you talk through how that works in AI?
Sure. With induction, you start by observing specifics like, the sun's come up every day so far, and then you guess it'll rise tomorrow. You don't have a formula, but you've spotted a trend.
But there's always a risk, right? Just because something's happened 1,000 times doesn't guarantee it'll happen again.
Exactly. Inductive reasoning gives you probabilities, not certainties. That made a lot of the early AI crowd uneasy, since their conclusions could get overturned with new evidence.
Building on that, this split kind of led to the terms we hear now, symbolic and subsymbolic AI. I always get those mixed up. Can you help set it straight?
No worries, here's the gist. Symbolic AI is tied to logic and rules. You define symbols and relationships, and you feed the computer your expertise. Think expert systems that follow set guidelines.
And subsymbolic is more about learning from patterns, right?
Exactly. Subsymbolic methods like machine learning and deep learning don't rely on explicit rules. They let algorithms find patterns in data, mimicking how our brains process information.
So let's zoom in on symbolic AI for a second. I always hear about expert systems. What were those and how did they actually work?
Expert systems were these clever, rule-based programs designed to mimic human specialists like radiologists diagnosing MRIs. They worked by encoding tons of domain-specific rules and logic, all provided by people.
That's cool, but it sounds pretty limited. Like, if you didn't program the rule in advance, the system just wouldn't know what to do.
Exactly. They were super effective in narrow fields, but couldn't really handle surprise scenarios. Still, for healthcare and similar domains, they made a real impact.
Now for the subsymbolic side, this is where things get really interesting, especially with neural networks. The Perceptron was the first of these, right?
Yeah, the Perceptron was like the OG artificial neuron. Frank Rosenblatt built it in the late 50s. It worked by taking a handful of inputs, multiplying each by a weight, and then making a yes or no decision.
So, kind of like a really simple brain cell, check the numbers, sum them up, and spit out a 1 or 0, but it needed feedback to improve.
Exactly. It learned through trial and error. If it got something wrong, it'd tweak its weights and try again. That's supervised learning in its earliest form.
But the Perceptron also hit a wall, right? Some critics really pushed back on it.
Oh, totally. Minsky and Papert, the big names in symbolic AI, published a book basically saying, the Perceptron can't solve complex problems. That critique made funding for neural networks dry up almost overnight.
That must have been brutal for the researchers invested in the subsymbolic approach. Makes me wonder, did anyone keep pushing forward or did everyone just give up?
A handful of stubborn folks kept at it, thankfully. Otherwise, we wouldn't have the deep learning breakthroughs we see today.
That whole episode triggered the infamous AI winter, didn't it? I've heard it compared to all those tech booms and busts we get hyped, overpromise, then crash when stuff doesn't deliver.
Exactly. Expectations soared, but symbolic AI just couldn't live up to the grand visions. When results stalled, investors and governments started pulling the plug. Research slowed to a crawl, labs closed, and AI kind of disappeared from the public eye.
The irony is, some expert systems quietly kept working behind the scenes, especially in healthcare, but no one was exactly lining up to write headlines about that.
Totally. The media loves a breakthrough, not a slow and steady system doing its job.
Eventually, things started heating up again, though. Deep learning came roaring back, and suddenly everyone cared about AI all over again.
Yeah, it's wild. Once deep learning, especially neural networks, started outperforming old approaches, a new wave of investment and excitement followed. Suddenly, AI wasn't just back, it was everywhere, powering voice assistants, image recognition, you name it.
This time, though, it's subsymbolic methods leading the charge. No more strict rulebooks, just mountains of data and pattern-hunting algorithms.
That's right. But even now, the field's way more diverse. Symbolic and subsymbolic approaches sometimes get blended, even if deep learning gets the spotlight.
Seeing all these cycles, hype, disappointment, rebirth, makes me wonder, are we heading for another AI winter if things go south again?
That's a fair worry. Tech tends to move in waves. When ambitions outpace reality, a downturn often follows. But I think the lesson is clear. Balancing big dreams with realistic expectations matters so much.
So every wave teaches us something: the limits of hype, the need for grounded research, and maybe a bit of humility.
Exactly. Researchers now try to learn from the past and keep ambitions and outcomes in sync. Otherwise, history might just repeat itself.
What I keep coming back to is how AI isn't just about tech, it's got this whole philosophical side too. Like, what even is intelligence? Where do we draw the line between code and cognition?
Absolutely. And that's part of what makes AI so fascinating. It's the only field I know where breakthroughs in technology force us to wrestle with deep questions about what it means to think, to learn, to be intelligent.
And as the field keeps evolving, I feel like it's on us, today's researchers, developers, and honestly, the public too, to guide where AI goes next.
Couldn't agree more. Balancing optimism with skepticism, keeping values in mind, and staying alert for unexpected side effects, that's how we make sure AI helps, not harms.